This method is used to replace damaged or missing circuits on internal layers of multi-layer circuit boards. The minimum skill level needed to complete this procedure reliably is expert. The conformance level reached when this procedure is completed properly is high. See the web page for a list of the tools and materials required to complete this procedure. The procedure follows. Step 1. Locate and determine the coordinates where the repair is to be made. Use films or master drawings of the board as needed. Note: obtain as much information as possible on the conductive and non-conductive layers prior to starting the procedure. Step 2. Remove components from the immediate area, if necessary, and clean the area. Step 3. Use the microscope and micro drill system and cut through the base material, one layer at a time, until the desired inner layer has been reached. Use caution. Great care should be taken to prevent further damage to internal circuits. Step 4. Each internal circuit should have a flat section exposed to allow the new circuit to be soldered in place. Note: to reduce damage to the internal circuit, complete the final exposure of the internal circuit using a knife. Step 5. Remove all loose material. Clean the area. Step 6. Apply a small amount of liquid flux to the ends of the internal circuit. Tin the exposed end of each circuit using solder and a soldering iron. Step 7. Clean the area. Step 8. Select a circuit track to match the width and thickness of the circuit to be replaced. Cut a length approximately as needed. The circuit track should overlap the existing circuit, a minimum of 2 times the circuit width. Step 9. Gently abrade the top and bottom of the circuit track with the buffer to remove any protective coating and clean. Note: if needed, the ends of the circuit track may be tinned with solder prior to lap soldering in place. Step 10. Place the circuit track in position. The circuit track should overlap the existing circuit a minimum of 2 times the circuit width. Note: if spacing is critical or the circuit board uses high-frequency circuits, bevel the joint. Use caution. This bevel joint method may cause problems with circuit boards exposed to extreme temperature fluctuations. Step 11. Apply a small amount of liquid flux to the overlap joint. Step 12. Lap solder the circuit track to the exposed internal circuit using solder and a soldering iron. Make sure the new circuit is properly aligned. Step 13. Clean the area. Note: the circuit board may be preheated prior to filling the area with epoxy. A preheated PC board will allow the epoxy to easily flow and level out. Epoxy applied to an unheated circuit board may settle below the circuit board surface as the epoxy cures. Step 14. Mix epoxy. If desired, add color agent to the mixed epoxy to match the circuit board color. Step 15. Coat the top and sides of the replaced circuit with epoxy. The epoxy bonds the new circuit to the base board material and insulates the circuit. Continue adding epoxy up to the top surface of the circuit board or to the height of the next internal circuit. Note: a slight overfill of epoxy may be desired to allow for shrinkage when the epoxy cures. Step 16. Cure the epoxy per Procedure 2.7 Epoxy mixing and handling. Use caution. Some components may be sensitive to high temperature. Step 17. Add additional circuit tracks if needed and coat with additional epoxy. Step 18. Continue completing all layers until the top surface of the circuit board is reached. Step 19. Clean the board as required. Step 20. Apply surface coating to match prior coating as required. Evaluation. Step 1. Visual examination for alignment and overlap of new circuit. Step 2. Visual examination of epoxy coating for texture and color match. Step 3. Electrical tests as applicable.